Hello everyone, welcome to the third installment. So that's all we have to look at now is the empirical rule, or the 68, 95, 99.7 rule. And that gives us a quick way to estimate some probabilities on things that are approximately normally distributed. So that means that they have a bell shape, they're symmetric, they essentially look something like this. And basically what the empirical rule says, right? It says that 68% of observations are within one standard deviation of the mean. 95% are within two standard deviations. And 99.7% are within three standard deviations. But we use some symmetry arguments to break that down and see what all the pieces would actually look like. So if we make a normal curve like this, again, we can try to look at what those parts, so if we call the middle part the mean, so say that's mu, and we look one section over, that would be half of 68%. So this would be, say, maybe mu plus sigma. So remember, mu is just the mean, and sigma is your standard deviation. So we're just counting by multiples of those. So this section right here would be 34%. And then this section right here, from mu plus sigma to mu plus 2 sigma, this would be 13.5%. And then mu plus 3 sigma. So the section from mu plus 2 sigma to mu plus 3 sigma would be 2.35%. And then you have the part that's left over in the tail that's approaching. So this tiny little bit right here would just be 0.15%. So we use the symmetry arguments to figure all of that out. And essentially, if you remember that and the fact that it's symmetric on the other side, so if you did mu to mu minus sigma, that would also be 34%, then these problems aren't too difficult. So let's look at a concrete example. So let's do the standard one that people always like, suppose, or we could say IQ scores are known to be normally distributed. With mean equal to 100 and standard deviation of 15. So if we're going to get asked any questions on our empirical rule, essentially we just need to make sure that we create our little picture and we count on all the important multiples. So this would be 100 right here in the middle, then we have 115, so 115, 130, and 145. And counting below, we have 85, 70, and 55. So you just count by multiples of the standard deviation, which here is 15, and you could basically answer any kind of question. So we could say, what's the probability that somebody scores between 115 and 145? So that probability, we would typically write probability of 115 less than or equal to x, less than or equal to 145. So that would be this section right here, which we saw was 13.5%. Plus this section right here, which is 2.35%. So the probability would just be the addition of those, 13.5 plus 2.35, and we come up with 17.85%. That would be your answer. And you could do it between any one of those. You just pick your sections and add them together. Sometimes you can be a little bit fancier if you want to, make some kind of argument based on it being half, like, but typically just adding together the sections that you know is the easiest way. We could do another one. What's the probability, let's say, that somebody scores less than 70? So probability of x less than or equal to 70. So that would, again, just be the two smallest sections. So we know this is 2.35. And this one right here is 0.15. So we get, and those are both percentages. So 0.15 plus 2.35. And we come up with 2.5% as the probability. So the main thing, just remember the chart. So your key sections are 34%, 13.5%, 2.35%, and 0.15%. And they get smaller the farther you get away from the mean. And then when you create your table, you start by finding the mean, and then you count up and down. So you make your tick marks by 3 multiples of the standard deviation above and below. So in this case, it was 15, so we did 100. Then up 3 counting by 15, 115, 130, 145. And then down 3 counting by 15, 85, 70, and 55. And knowing that, you should be able to answer any of the questions based on these multiples of the standard deviation, and it's going to give you a really good approximation of the actual normal values that we'll use StatCrunch later to find exactly in the semester. So that wraps it up for the last topic, and if you have any questions, just shoot me an email, and if anything wasn't covered in enough detail, let me know and I can create some new content. But have a good weekend, and good luck studying.